Hey everybody, it's Brian at Summit Racing. Welcome today. Oftentimes here at Summit Racing, we have a lot of vendors here. We carry a ton of different brands, very first-class people and companies that have been in the business for a long time. Today, I'd like to introduce to you Lake Speed with Total Seal.
Thank you, Brian.
Yeah, so he's coming in. He comes in maybe once a year or something like that.
Something like that,
kind of common. But anyway, so this is an awesome opportunity for our customers. Engine builders, enthusiasts of all different stripes, I don't care what you race, whether it's marine, whether it's cars, motorcycles, this guy knows piston rings, and we're here to learn a little bit about that today.
Oh yeah, thank you, Brian, I appreciate it.
All right.
Like I said, the piston ring is this ubiquitous thing that everybody has got, but not a lot of people know a whole lot about it.
It's true.
And there's more than meets the eye. It looks pretty simple and plain and basic. But one of the things about a piston ring that is universal, regardless of what brand piston ring you buy, is that end gap.
Yes.
And it is a critical part of how your engine will perform. If you have too much end gap, a lot of blow by, because this is a leak path. Mm-hmm. But if there's not enough end gap, as that piston warms up, those end gaps butt, bad things happen.
Potato chip.
Bad day at the office if your piston gap's too tight. I always say, a little too loose, no one knows. If it's too tight, everyone knows.
Right.
So setting that proper end gap, really important to performance and longevity. And you guys have some pretty cool tools here to help people set that correct end gap, because you got to get it right. And piston rings come in, when you order them, a couple different ways.
Yes.
You can get what they call a drop-in set that's, we'll call it somewhat pre-gapped to say a standard SAE type spec. Or you can get what's called a file-to-fit set. A file-to-fit set is usually 5/1000 oversized on the top and second ring. That way you can actually tighten that gap up if you need to.
Right.
The other thing you need to think about too is not every engine's naturally aspirated. Not every engine's running on gasoline.
Boost, nitrous.
Right. So with those different factors, you got to start opening that end gap up, maybe based on how much power you're making.
Right. Well, okay, so we have our customers here. We have everybody, from, hot rodders with an old, 350, for instance, where they may lay into it for a 13-second quarter-mile run. They're running a cast piston. And then we've got guys that are 30 pounds of boost, they're wide open for 5 seconds down the quarter mile, sometimes less. And then we've got marine guys, or we've also got land speed guys, which are 2 minutes, foot to the floor across the salt, or, if you're driving a boat across the lake, wide open throttle at full engine load. And so each one of those has, different, properties in terms of how much, wicking is going on of, the water temperature pulling heat. I don't know if a lot of people know this, but the way that a piston actually gets rid of the heat that would otherwise melt it is actually through that little piece. So the piston transfers through the ring, and the ring touches the cylinder wall, which is touching the water jacket, and that's how it's actually dissipating. So that little tiny ring surface is actually basically dissipating the heat that the entire top surface of the piston is seeing. And because of that, now your ring gaps are trying to butt. And we were talking about the potato chip effect. Well, when they butt, it needs to go somewhere. It can't go out any further. So it actually turns into basically a Pringles potato chip, if you can imagine what that wave looks like. And when it does that, it lifts the ringland. And what you used to have as being, 1 or 2 thousandths of vertical clearance is now 10. And that, in the worst case, if you have a cast piston, you can snap the top ringland off. Even worse, you can snap the second land off, and it kind of stays in there, and you don't even know it when you do a blow-by test. But you don't have all of the piston in there anymore, and you don't know why you have blow-by. And it looks good, but it's still huffing oil. You don't know why until you pull the piston out of the engine, and you have pieces of second ringland just basically falling out of the piston. So these are all things that happen, and you guys do a great job, with the instructions of showing if you've got this application, 4 thousandths worth of bore. Can you explain that concept?
Yeah, so what we call is the end gap factor. And in fact, it's a great thing to bring up, because sometimes people get confused and they hear end gap factor, and maybe the factor is, say, 4 thousandths, or maybe it's 7 thousandths.
Yes.
And they think, well, that's how much gap to put. No, that's a factor where you multiply that factor by the bore size to determine the actual proper end gap. So say, for example, you had a 5-inch bore with a 4,000 end gap factor, well, that's 20 thousandths.
Versus 16 on a 4-inch bore.
Exactly.
Right.
So, and that 4 thousandths end gap is usually for a lower compression, gasoline, naturally aspirated engine that's really just daily driver. Okay. And there's some guys who high performance, like crazy NA stuff, might get a little bit less than that just because they're they're hardcore guys, right? But what happens typically is that you get into boost, you get into nitrous, okay, you're generating more heat. And like you said, this part is going to grow, so now that gap gets tighter, so the chances of it butting are greater. So what do? You increase that factor, say from 4 to 6 or to 7, depending upon how much cylinder pressure you're making, because cylinder pressure is heat typically.
All right.
So more factor for more boost.
All right, so this is a great one. And this goes back as long as I've been in the business is, all right, so some rings, I mean, you think about a top ring, how much heat it sees versus a second ring. And so back in the old days, it was, you have your top ring, say at 15 thousandths, and then your second ring might be 12 thousandths. And then that switch, that thinking is kind of switched.
Yep.
So now you've got a bigger gap than the top. Can you explain the reasons why people would do that?
So, okay, the perfect question actually. So that old school of having the same gap for the top ring and the second ring was based on that idea, okay, we know that top ring is going to grow more, so the second ring won't grow as much, so it gives that little bit of path to let some of that blow by energize the oil ring.
Yes.
Because that's the thing we're not talking about, is the oil ring is part of that ring package. And anybody's ever seen their piston, there's drain back holes in the back of the thing. So we know you're scraping the oil off and it's getting there.
It's got to go somewhere.
It's got to go somewhere. Well, with a little bit of blow by can actually assist that and push it through so that your oil ring is active and working.
Right.
So what's happened with today is we've gone to lower tension oil rings. So now we want to have a little more gap to energize those oil rings so they work. So the lower the tension you go, especially say in a dry sump engine where you pull in vacuum, you need that path to move it through. In fact, that's one reason why even with say a gapless piston ring, you actually need to gap it. Both the ring and the gapless rail need to be gapped. And the key thing is you got to gap them 50% more than a standard ring, at least 50% more.
So I got to learn about this before this segment, the reason why. Go ahead and tell them why.
Well, back to this thing is going to pull really hard on the intake
vacuum.
stroke.
So we think about the intake stroke, your cylinder is filling up, with air, and it's actually that ring that's creating the seal there. Well, you've got a lot more vacuum, and when you have a vacuum on top of something and you have pressure below it, you're naturally going to want to have this oil migrating to the top of the cylinder. When that happens, you get oil basically smoking out the exhaust. So no good.
Yeah, because the oil is going to follow that path of least resistance.
Right.
If there's a low pressure here, it's going to go where it is.
Right.
From high pressure to low pressure is where it's going to move. All those gases, all that. So by opening that gap up a little bit, you're softening that.
Right.
That way, one, it's going to hold a little more heat too, because it's touching each other and there's more material there. Secondly, is you want to let that path happen a little bit. You need to let it breathe a little bit, because if you had a true zero gap ring, nothing, whoo buddy, you better have some crankcase vacuum.
That's right, that's right.
To offset it.
Well, and it is weird. So there's lots of different factors. You can't just think about the idea that if you open ring end gap, that you think that, wow, that's going to let more oil go by, but it actually works the opposite way. But you guys have done really a lot of thinking on this, years and years and years of experience with the best engine builders on the planet.
Exactly.
And so you guys have, really good ideas on this. And you bring up another thing. So a lot of our customers here at Summit Racing, there might be street enthusiasts that don't have dry sumps or vacuum pumps, but it really is becoming more common. Those systems are becoming more user-friendly. They've got systems that work with AC.
Yes.
Some of the factory cars, whether it be like a Z06 or like a Porsche GT3, are now coming with dry sump, systems from the factory.
Yes.
C8 Corvette comes with a middle-of-the-road dry sump. So can you explain to us a little bit about that pressure differential on the top of the piston versus in the crankcase a bit?
Yeah, sure. So the idea of having crankcase vacuum is to assist windage, essentially, right? A couple things are going to happen. One, we know that windage is what the crankshaft and the pistons and rods are all moving through that, and that's just, robbing you of power.
Right.
It's no different than trying to go, run down the street or run to the swimming pool. One's easier than the other, So the more windage you can pull out of there, the faster that engine can accelerate, the more power it's going to make.
Right.
So that's one thing. Other thing too is back to that pressure differential.
Yeah.
On that intake stroke, if I've got a high crankcase vacuum, it's pulling that ring down flat. So that's another thing too we're going to get into real quick here. Most people think that a ring is only sealing on that outside diameter against the cylinder wall, that's the seal.
Right.
Nope. Most of that seal is actually on the flat of the ring against the ring groove.
Yeah.
The flat of that ring groove can be in the piston, and the flat of that ring can be, the more seal you get.
Exactly.
I mean, that's where the total seal diamond finish ring, that's really what set us apart from everybody else, is the flatness of that ring.
Well, and the piston manufacturers, they used to have about, really, if you had something that was 3.5 thousandths worth of vertical clearance, you were doing like, okay, that was considered to be performance. In this day and age, it's more like half a thou to a thou worth of vertical clearance in there. And the reason why we do that is to keep that ring, say we're going 8,000 RPM, it's got its own mass. You're trying to keep it flat and square, to the cylinder, and it can't really do that very well if it has a bunch of clearance in the groove.
The wider that vertical clearance is, the more ring there is. Talk about ring flutter, that's where it comes from, is all that vertical clearance. Like you said, there's mass of that ring. The higher the RPM you go, that mass essentially becomes greater, right? So it starts to want to travel and unseat itself off that flat. So that's the whole idea of that crankcase vacuum, holding that ring flat, seeing that pressure differential. That way on that intake stroke, it's more efficient on the intake stroke from the very beginning.
So Total Seal, they've got many firsts in the industry, and they were actually the first to do diamond lapped rings. And in other words, the rings would come, and if you put them on a table, they would be kind of like, you could actually even see like one end would be kind of sticking up a little bit. The ring looked kind of flat, but it wasn't. And so you guys were going in there and surfacing them, and then the racers would get and work with the piston manufacturers to get cutters, that would actually tune the groove in around wherever you cut the ring in terms of flatness. And then we've got that, we look at a 5/64 ring, and
it's a dinosaur.
Yeah, you and I are just like, no, 5/64 rings, and we just imagine that tension of trying to yank that piston.
That poor cylinder bore.
Exactly, and so a lot of people think that a 16/16, 3/16 is performance. It's not. The stuff from the factory these days is a 1.5 or a 1.2 or a 1.0, and so when I say millimeter, what does that work out to? A 1.5 is about 60 thousandths, which is only 2 thousandths less than a 16th. But the radial tension, basically it's from here to here is much smaller. When you have this thing as a 1.5 millimeter versus a typical 16th ring. So even though it's the same size vertically, it has much less radial on it, and that gets rid of a ton of tension, goes up and down the bore, less friction, more horsepower, better everything. And then, we've had 043s around for a long time. Really, a 1 millimeter is a 040. So again, similar. But we're going from something that was 210 thousandths worth of radial down to 160 to 140. And then you guys have people probably getting down into the 0.7s. I mean, can you even talk about?
Oh yeah, we made 0.5. That's 20 thousandths.
All right.
That's the thickness of a lot of oil rails, actually. But they work great. I mean, if you think about it, we were talking earlier about the Japanese motorcycle engines.
Yeah.
They've been running 1 millimeter or less for decades.
Right.
And think about how many you see out there.
Right.
The thin ring technology isn't something you should be scared of. Now back to ring gap, well, what does that mean? When you go from that big thick ring and you start going down to that thinner ring, the materials change, right? So you do. You want to run a little bit more in gap with a thinner ring. So for example, when we did some testing at Shavers last year on the gas ported rings, which we'll talk about in another video, we went from a 16th ring that was gapped at 22 thousandths, right? We went to a 0.7 millimeter ring Right, so that's 27 thousandths.
Yeah.
Right, for 16th was an 062.
062
to
half.
a 027, right? Yeah, cut it in half, right? we went out to 30 thousandths.
Yeah.
Just so you wouldn't butt it. And one way you can know if you're having a problem butting a ring is you can actually read the ends themselves. If you see them shiny and there's metal transfer, that's an indication that your rings are butting. You need to give it more end gap.
The other thing that you can see is on the area opposite of where that gap is, you'll see a flat, shiny spot on the top or bottom, because on the exact 180 degrees opposite of that gap is where it's trying to start flexing and moving up.
Yep.
So yeah, you can also see this on the top and the bottom surface of the ring. But you know, it's cool for engine builders how it's such an art form to diagnose things when you're trying to just get that last little bit of horsepower, you know?
Oh yeah, well, it's Larry Wallace, one of my heroes in engine building. If you've ever been around Ford stuff, you'll know who Larry Wallace is. If not, look it up. His line to me was, if you go to Mount Everest, all the dead bodies are at the top of the mountain, not at the bottom.
That's right.
Because it's pretty easy to move around down the bottom of the mountain.
Right.
Low horsepower, you can get away with all kinds of sins. It doesn't kill you.
Right.
When you get up here, yes, the things that were small actually are quite large in effect. So the small details make a big difference when you really get to the top of that power.
So we've had a big movement really in the last 10 years of people, this is the craziest thing, but you know, people pulling engines out of junkyards forever, and and now with the advent of modern fuel injection and turbos that are $300 off of eBay, you know, you can go ahead and boost this thing to 850 horsepower, whatever the number is, and you can do that with a 4.8 liter if you gap the rings a little bit.
Yes, exactly.
All right. So in other words, taking this junkyard engine with 150,000 miles out of it, and you just go in there and open up the ring gap from about 10 or 11 thousandths up to maybe 30, 31, 32.
Yes.
It depends, right? But yeah.
I'd go at least a factor of 7 on bore size if you're going to put some serious boost to it.
Right. But now all of a sudden, you know, things are living a little bit longer. You know, before you end up having to go with forged pistons like our Pro LS, you know, piston, for instance, it just gives you that much overhead. And then, you know, when you're at 850 and you're starting to bend rods, then you step it up into a Pro LS piston and connecting rod.
Yep.
But do you want to talk to us a little bit about, you know, really what you've seen in terms of street guys, you know, doing this type? And, you know, because I think about a street piston where they're going for emissions.
Right.
So they want air and fuel burned as much as possible, and really even in super stock in those types of classes where the top ringland might be like 80 thousandths,
right,
to try to keep all that air and fuel up in the combustion chamber rather down around the top land where it doesn't get burned.
Right.
They would try to raise that ring as much as possible, but when you do that, you're exposing it to more heat.
That's a great point. Yeah, the higher the ringland is on the piston,
Yes.
the closer it is to the heat. Yes, it's going to grow more. So now you need to compensate for that with end gap, especially if you're going to be we talk about adding boost. So if you're an NA guy and you go from, say, a piston that was, say, 300 thousandths down in the ringland, top ring, and now you go to one that's 150, you're going to have to change your end gap and open it up some to compensate for that. Or vice versa. If you go down, you need to tighten it back up to get to that same operating place.
Yeah, so people, that happens all the time. You know, almost any of our Pro LS pistons have a 300 thousandths top land. It's there for boost because we know that you're going to be running big nitrous, big boost or anything. So we run, you know, that 300 thousandths top land. And when we do that, you know, those end gaps tighten up to 21, 22, 23 instead of 30, 31, 32. So there's other benefits in terms of blow by, you know, when the engine is cold or colder before it's, you know, warmed up to running a forged piston. So these are all things to consider, you know, when you're building your engine. You know, what a great resource to have you here in the studio today with us.
I appreciate it. I got one more curveball change up for you too.
All right.
The direct injection engines that actually happen to have piston oilers, yet another factor, because we said, hey, this is the thing that's transferring all the heat. Well, there's actually one more thing in there. It's the engine oil.
Yeah.
The motor oil. And when you have a piston oiler that's actually spraying the piston, it's actually able to pull heat out of the piston as well. Right. So that's one other factor to keep in mind, that, hey, you may have a buddy that says, hey, you know, I got the same bore size as you, same displacement engine, making about the same amount of power. This is the end gap that I'm running.
Right.
But if you've got a DI engine that's got piston oilers, you probably don't want to run that much gap. You can probably run a little bit tighter because you're getting more heat pulled out of the heat from the piston just because you've got piston oilers.
Right, and so we think about modern engines that have that. So like a Cadillac CTS-V, you know, an LSA or like an LS9 used in the ZR1, those have piston squirters.
All the LT1s, LT4, LT5 from GM has it now.
Yeah, all the Gen 5 stuff. A lot of Japanese engines have been running that technology.
The Godzilla motor's got it too.
7.3, baby. So yeah, it's awesome. So a lot of people would, back in the old days, they would just kind of yank those things out because really it's just windage. You know, if you don't need it, you don't need it, and you try to get rid of any oil that's just kind of flying around the crankcase. So there's another case of like, are you going to be drag racing where you don't have that much time to put heat into a part and you're trying to reduce windage? That would be a case for getting rid of an oiler. Now, if you're like GM, where they want to basically go 100 hours at wide open throttle in a test and have this thing live for 150 or 200,000 miles, then you have squirters to keep the piston from annealing.
Right.
So there's many considerations there.
Oh, there's tons, which is one reason why we always tell people, if you've got any questions about this stuff, if it seems overwhelming, just give us a call.
Right.
We've got really experienced tech guys.
Very much.
That have been building engines their whole life, that know what they're talking about. You can just give them a call and they'll talk you through it, help you find the right guidance so you get in the right path. Because at the end of the day, we want everybody to be successful.
And that's the thing. So we have all of these different piston rings on the Summit website. So it's really the way that our website works is you have your what we call left-hand navigation. So it's a matter of picking your bore size. It's a matter of picking usually your top ring thickness will give you an idea whether it's an 043, 043 mil, 16/16, 1515, etc. So you can kind of start picking through those filters. You will find filters for file fit or not. You'll find filters for gapless or not, and it's a great way to help people zone in on exactly what they need for their application.
I use it all the time.
Right, it's awesome. All right, well, anything else you want to share with us today?
No, thanks for letting me come in, and I hope everybody enjoyed the video and learned a little bit considerations about ring end gap.
Yeah, so we've got some other great videos too. We're going to go ahead and we've done one basically on Total Seal as a company in terms of what they've been doing up for the last 10, 15, 20 years really, and the general trends of things. We've got another one on ring filing and some other pretty cool tech as well. So if you want to see some more great videos like this, please be sure to like, subscribe, ring the bell, and you'll see more great stuff from Blake and our other vendors.
Exactly.
All right, see you guys.